Hey everyone, welcome back. Today is the day 6 of our vector databases 0 to hero series. In this video, we will explore the key components of a vector database, and we'll also see how these components work together to make the similarity search extremely fast and scalable. So by the end of this lecture, you will have a solid understanding of how a vector database store, index, and retrieve high-dimensional vector embeddings efficiently. So without wasting any time, let's dive in. Now let's learn the high-level design of a vector database. So earlier we learned the high-level pipeline of a vector database. Now let's try to understand how the internal architecture of a vector database looks like. We'll understand how a vector database actually stores vectors and how they index those vectors and how those vectors are fetched from the vector database. So here are the key components that you would come across in a vector database. So first, we have the API gateway, and then we have the indexing layer, then there's a query processing layer, and then we also have a storage layer. So these are the internal components that you will come across in every vector database out there. So the entry point to a vector database is always the API gateway. So the responsibilities of an API gateway is that this is what interacts with the vector database. And the responsibility of this API gateway is to expose those APIs so that the client application can store vectors, they can basically update vectors, they can read those vectors or delete those vectors. For performing all these operations, the API gateway exposes those APIs so that the client application can perform those operations. So that's the main responsibility of the API gateway. And it also exposes some APIs for querying those vectors. And one thing to note here is that these operations are different from querying vectors, because this is where you kind of perform these operations in the ingestion phase when you are actually storing those documents inside a vector database, whereas the query operation happens when you wanted to search something. So these are two different operations that any client application would perform in any vector database, and that's the responsibility of the API gateway, is to expose those APIs to the client application. So that's the responsibility of the API gateway. Then we have the indexing layer. The purpose of this indexing layer is to organize those vectors for efficient similarity search. And this is nothing new. You would come across indexing layer in any database, be it any traditional database like SQL, NoSQL. You have that indexing layer. Similar to that, even in vector database, you would come across an indexing layer. The main purpose of indexing layer is efficient similarity search and avoid the brute force search. So now for indexing, there are two techniques that most of the vector databases apply. One is IVF. Now IVF stands for inverted file index. Okay, this is one technique that most of the vector databases use for indexing, and there is one more popular indexing technique, that is HNSW, which stands for hierarchical navigable small words. So these are the two key techniques that most of the vector databases apply in the indexing layer. And as I said, the main responsibility for the indexing layer is to enable fast search, right? Low latency search, so that you can search millions of vectors inside this storage layer efficiently. That's the purpose of this indexing layer. Next, we have the storage layer. Now, storage layer is obviously for storing those high dimensional vectors efficiently. And The main feature of any storage layer is obviously fast insertion, fast retrieval, and fast deletion. Those operations should be extremely fast. And then the storage layer also ensures that there is high durability and high reliability. Now, how it enforces high durability and reliability is by replication. So this layer can be replicated for any fault tolerance, and there could be even partitioning done if you want to scale. So you need to do partitioning. These are all the fundamental techniques that you would find in any database, and those techniques are also available inside any vector database that you would want to use for production grade solutions. So that's the responsibility of this storage layer. And then there is another layer that is for the query processing layer. Now this layer handles any query vectors. So whenever any client application, they search any query vector, it's always the responsibility of this query processing layer that ensures that this incoming query is handled efficiently. So the responsibility of this query processing layer is to handle those incoming search queries, and then this layer coordinates with the indexing layer and the storage layer. And this is where it uses those techniques of filtering and ranking those results once those results are fetched. So that's the responsibility of the query processing layer. So just to recap here, these are the key components that you would find in any vector database. So you have the API gateway, which is like the entry point. Then you have the indexing layer that ensures that whatever you search is always fast and efficient. Then you have the storage layer, which is for your data persistence. And then you have the query processing layer that always ensures that the query vectors are matched against whatever is stored inside this storage layer. So these are the 4 key components that you would find in any vector database. Hope you found this video useful. See you in the next one. Thanks for watching.